Okay, coming to the second example on bivariate probability distribution. Bivariate has two variables. Okay, so when you have two variables and the probability distribution has been given, we call it to be bivariate probability distribution of x and y. It's been given in the table. This is a favorite question again for the examiner, and then it's a short question. Okay. Um, Right. So these are all the probabilities. Y value is ranging from 1 to 6. X is ranging from 0 to 2. Now we are being asked with different questions. What that is of course, by default, you can go for finding out the marginal distributions of X and Y. That would be one good thing which I will suggest before going for finding out the remaining things. Once you finish off finding marginal distributions of X and Y, the remaining values can be easily found out. And you can clearly see here, you have conditional probabilities kind. Okay, P of X less than or equal to 1 for Y is equal to 2, P of X less than or equal to 3 for Y less than or equal to 4 kind of things. Okay. So let's start with doing marginal distributions of X and Y. Okay. Yeah. Marginal distributions. Again, I can write them down in the table of X and Y both. I can write them down in a table. Okay. So it will be something like this. Of course, Y values are many in number. This is X. This is Y. X is ranging from 0, 1, 0 to 2. Y is ranging from 1 to 6. 1, 2, 3, 5, and 6. These things on the right would be Px of X. And then these things below would be Py of Y. Yeah. So 0 and 1, are there any values? 0 and 1, the value is 0. Okay. 0 and 2 also the value is 0. Okay. Yeah. Now coming to 0 and 3, the value is given to be 1 by 32. 0 and 4, the value is given to be 2 by 32. 0 and 5, the value is given to be 2 by 32. And 0 and 6, the value is given to be 3 by 30. Of course, you can call them to be the marginal distributions only. I don't think you need to write, but then I'll take the sum here, the sum of all the rows and the columns. The sum of all the rows would be 8 by 32. I'll just write in this table just to save time. 1 plus 2, 3, 3 plus 2, 5, 5 plus 3, 8, 8 by 32, this is. And this one would be what? Of course, here I'll be having 2 and here I'll be having 2. So 4. No, these are ones only. I'm sorry. These are ones only. Here I'll be having 2s. Okay. So 1 plus 1, 2, 1 more 2, 4, 6, 8 and 10. So this would be what? 10 by 16. Okay, and again here also I'll be having, here also it is 2, here also it is 2. Okay, so 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8. So it would be 8 by 64. Of course, I have to take sum of all the probabilities and it should turn out to be 1, right? Similarly here, this is Px, P suffix X. This is P suffix Y. Right, so these would be what? 2 plus 1, it is 3 by 32. Here also it is 3 by 32. And then here it is 8 and 64, na? So 8 and plus 1, 8, 8, 64. Okay, so something like 11 by 64. And then again here also 13 by 64. And then here I'll be having 6 by 32. And then here I'll be having 16 by 64. Okay, now again you sum up all the probabilities. 2 8 is 16 plus 10 is 16 plus 10 is 26. No, not like that. I should be taking LCM. So 8 plus 16 4s. So 40, 48. The 32 twos is 16. 48 plus 16 would be what? 64. So 64 by 64 is 1. Similarly, here also you can check, guys. All of them would give me 1. Or summation P of x is equal to 1. Summation P of y is equal to 1. Now this will save my time to calculate remaining things. Okay. I'll just show here. Marginal distributions are this. I'll be constructing the marginal distribution table once again. Rewriting the table with all the sum of the probabilities of the rows and the columns. Okay, that I should do it for the exam's sake. Now coming to the first problem. What that is P of x less than or equal to 1 and y is equal to 2. Y is fixed and x is varying. So how will I write this? P of x less than or equal to 1, what are our values are there? X is equal to 0 is 1 value, y is equal to 2 only. X is equal to 1, one more value is there, and y is equal to 2. Okay, this is okay. Fourth one is a bit tricky thing, which I need to look into. P of x is equal to 0, x is equal to 0 is this, and y is equal to 2. Y is equal to 2 would be what? This one only, which is 0. Plus P of x is equal to 1 is this, and then y is equal to 2 would be 1 by 60. Okay, so totally this value is 1 by 60. That's how I'll calculate. Okay, yeah. Let me do the last one as well first and then come to the remaining ones. Okay, P of x less than 3 and y less than or equal to 4. How many values will be there? I just need to check. How I'll be writing is P of x is equal to 0, y less than or equal to 4 plus P of x is equal to 1, y less than or equal to 4 plus P of x is equal to 2 and y less than or equal to 4. Okay, so just see here. Y less than or equal to 4, how many values are there? See this, 1 by 32 and 1 by 32 for 0. For 4 values are there for 1. And then 4 values are there for 2. So accordingly, I'll be writing. Okay, yeah. Y less than or equal to 4, how many values are there? For x is equal to 0 is 0 plus 0 plus 1 by 32 plus 1 by 32. I'm sorry, 2 by 32 that is. Okay, plus x is equal to 1 and y less than or equal to 4. How many values are there? 1 by 16 plus 1 by 16 plus 1 by 8 plus 1 by 8. Right? Next. For P of x is equal to 2 and x less than or equal to 4. 1 by 32 plus 1 by 32 plus 1 by 64 plus 1 by 60. Like this, all values are there. You just need to add them and finally you'll get the answer. I have the answer by the way. It is 9 by 16. Okay, that's the fourth one that I'll be solving like this. And second one and third one are a bit easy only. P of x less than or equal to 1. Okay, it's like the marginal distributions only. Okay, so I'll be calculating P of x is equal to 0 and P of x is equal to 1. Whatever value I'll get, I'll be substituting here. X is equal to 0, it's 8 by 32. Okay, yeah, completely. That x is equal to 0 row. X is equal to 1 row, it is 10 by 60. So finally, I'll add and I'll be getting something like 7 by 8. Okay. Third one, that's the reason I've written the marginal distributions. Okay, P of y less than or equal to 3. Y less than or equal to 3. How many values are there? P of y is equal to 0. No, the y values are ranging from 1 only. So no 0 is there. P of y is equal to 1. P of y is equal to 2. Y is equal to 3. Equal to is there. So 3 is also included. Okay. All those distributions. I can just show you once again if you want on the table. Yeah. Y is equal to 1. Y is equal to 1 is this. All these values I'll be adding. Y is equal to 2, I'll be adding all these values. Y is equal to 3, I'll be adding all these values. Okay. So it'll be something like y is equal to 1 would be 0 plus 1 by 16 plus 1 by 32. Okay. Plus y is equal to 2 would be again the same thing. 0 plus 1 by 16 plus 1 by 32 is what I have in the table. Okay. It's not something I've done it. Okay. 1 by 32 plus 1 by 8 plus 1 by 64. All these values I'll add. Again, I have the answer for the third one as well. It comes out to be 23 by 64. You can just cross check, solve and cross check. This is how I'll be solving. Okay. If I'm asked about only one variable, then I'll be looking at the other column and the different values. Okay. If y is the column, if x is the row. With this, I'll end this video and do one more problem. Interesting problem on joint probability distributions.